Ryan, and today I'm going to provide you a brief explanation for our project number 13, which is entitled as LCD-based distance meter. So for this project, we will be using an ultrasonic sensor, which will detect a certain distance, then display it on LCD. So let's start. First one, will be including our necessary libraries, and we have two of them here. First one is the liquid crystal underscore IC2.h, which is the library that is responsible for our LCD. Then the wire.h, which is responsible for the I2C and LCD communication. So next one will be our definitions. For the first one, we have this I2C address, which is a definition for addressing the I2C and LCD module. The next one for the LCD column 16, since the LCD have 16 columns in total. Then LCD rows 2, so 2 rows in total. Next one will be the initialization of these three definitions in one to properly initialize it on our LCD. And that is what I'm talking about. Yeah. Next one will be our constant integer trigger pin and echo pin, which is in the second and third pin of the Arduino. Next is for our setup function. First one will be LCD init, since we will be firstly initializing and opening our LCD, and we'll be simultaneously opening the backlight so that the LCD would be turning on finally. Next one will be the pinning modes of the trigger pin and echo pin. Trigger pin for output, then echo pin for input. Next, for our loop function, we'll be sending the ultrasonic pulse for our ultrasonic sensor. First one will be start as low, since it will start as no detection at all of any movement or any motion. And we will be inputting a 0.2 microseconds delay for it to finally detect before detecting the certain movement. Okay, so now it will be detecting the certain movement. We will be delaying a 0.10 microseconds delay. Then we'll be turning off the trigger pin. And next one will be the measuring of the pulse duration. So we will be assigning an unsigned long integer called duration, which is equals to our pulse and echo pin, which is the turning on of our echo pin. Next will be the conversion of the pulse duration to distance in meters. So float distance is equal to duration multiplied to 0.034, which is the speed of sound in air, and divided by 2 and divided by 100. Next one will be the displaying of the distance on the LCD. Okay, first one we'll be clearing first before setting the cursor or opening or initializing the LCD to work properly, and we'll be finally printing this tree. Yeah, there we go. The distance, which is on the 2 decimal places and have a unit of meters. Next one will be the delay of 0.1 microseconds, so that it will be delaying between the measurements on the LCD. That's all. Thank you.